Welcome to data compression. There's two basic kinds of data compression that are available within the SQL Server database engine. The first is row-level compression, and the second is page-level compression. Now, while these sound very similar, they're actually fairly different. So let's go ahead and dive into how these two different kinds of data compression actually work. First, with row-level compression, the first thing we need to know is that this isn't actually compression. What we're actually doing, instead of compressing data in the more traditional sense, is we're simply storing numeric values using the smallest possible numeric value to store them. So the classic example of this is to use a data type such as numeric 18,2. So it's 18 bytes wide, 2 of those bytes to the right-hand side of the decimal point, and we want to store numbers such as 3.5. Well, when we store 3.5 in this really wide field, it's always going to use the full 18 characters worth of data to store this information, which is going to be about 8 bytes. With row compression turned on, what we're actually doing is telling SQL Server to only store the 3.5. Don't store all the zeros on either side of that. So because of that, it makes the value much, much smaller that we're storing. So it saves a lot of space when we've got a lot of numeric values that are much smaller than the data type that they're actually being stored in. So because this only works on numeric values, obviously it has no impact whatsoever on any of your character columns. So char, varchar, varchar max, those sorts of data types, completely unaffected by row-level compression. So this is going to work really well on your numerics, your floats, and your decimals. Things like integer, big int, they'll have some impact, but the place where you're going to really get the biggest bang for your buck is going to be the numerics, floats, and decimal data types because they can be so wide and store such small values inside them. So let's go ahead and take a look at page-level compression and how that works. So with the row-level compression, where it only compresses the actual numbers that are stored in those numeric data types, now we're compressing actual text or character data. Now in SQL Server 2012, this also includes Unicode data, which could be compressed up until now. So the catch here is that we're only compressing data that's stored in row. So what I mean by that is that if you've got nvarchar max or varchar max data types with large values stored in them, where those values are overflowing to out of bound or to blob or lob data pages, those data pages are not going to be compressed. Only the actual on-row values are going to be compressed. So if a lot of your text columns are storing smaller values, those are going to work really well for data compression. It's the ones where you've got the really, really big blobs of text, and those aren't going to compress very well. Now, page-level compression doesn't just work on text data. It actually does row-level compression for the numeric columns automatically as part of the page-level compression process. However, because it does try to compress the text data as well, it is going to be a lot more expensive to turn on than turning on row-level compression if all you have is numeric data types within your table. Now, how useful page-level compression is going to be is going to totally depend on the data being stored in the table. If you've got a table that's storing lots of unique values and there's almost no duplication of data, then odds are you're not going to get very good data compression. But if your table is got a whole lot of duplicate values, like names, for example, that's probably going to compress fairly well, especially the indexes that are sorted by things like last name, because you're going to have lots of duplicate values on that page, so you're going to be able to remove a lot of them. Now, keep in mind that pages are only compressed when the page actually becomes full. So if you write a row to a new page and that row is 30 bytes, SQL Server is not going to bother to try to compress that page. It's only going to compress that page when the page fills. Whatever white space is now available, it will then fill. And once it becomes full again, it will then try to compress it again to try to save more space. SQL Server does this to try to save processing power, because if we were doing data compression on every single write, we'd end up spiking the CPU a lot higher than we do with the current implementation. Now, data pages are stored both in memory and on disk in a compressed state. So on disk, obviously that makes a lot of sense. We write the data to the database, the data gets stored on disk, the data is compressed. In memory, though, we're talking about the buffer pool. So the way SQL Server works is it reads the data off the disk, pushes it up into the buffer pool, and the buffer pool keeps that data in a compressed state. The only time SQL Server ever actually decompresses that data is when it actually passes that data to the query processor. Once it makes it to the query processor, then it's decompressed, processed, and used. And then once the query processor is done with it, there's no need to recompress it because the buffer is still clean. Or even if the buffer is dirty, we don't need to recompress it in memory. We simply throw it away from the query processor. When the buffer pool has a dirty page that's then full again, we then recompress it one more time. When we then write it to disk, we're already writing a compressed page down to the disk. So what data in your database can you compress? Well, you can compress just about everything. We can compress our clustered indexes, our non-clustered indexes. If we've got tables that are heaps, we can compress those as well. If we're using table partitioning along with compression, we can actually specify which partitions we want compressed. So maybe we only want the older partitions compressed, just to save space because they're not really used, but the most recent partition we don't want to have compressed. We can control that through the alter index statement that we use to turn on the compression and use the compression. Now, a question I get asked a lot is how do I know how much compression savings I'm going to get? Well, Microsoft thankfully gives us a stored procedure that actually will tell us this information. That is the sp_estimate_data_compression_savings stored procedure. Now, this stored procedure accepts 5 input parameters: the schema name, the object name, the index ID that you're planning on compressing, the partition number you wish to compress, and what kind of compression you want to do. So schema name, object name, those are fairly easy to figure out. The index ID, you can get that from sys.indexes. Just query sys.indexes where object ID equals whatever the object ID is that you want to look at, and give it whatever the appropriate index ID is. The clustered index is always going to be index ID 1. The heap will always be index ID 0 if you're working with a heap. If you specify null, it will run the stored procedure for all the indexes on that table. Specify partition number. If you're not using a partition table, just leave that as null. For data compression, you can either specify none, page, or row. Whatever value you specified is the estimate that's going to give you, using the table you specified as the data to use to figure out how much compression savings you're going to get. Once you've decided to turn on data compression, we do that with an alter index statement. We simply do alter index, whatever index we want to modify, on whatever table we want to modify, with open paren, data_compression equals either row or page. When we run that, once it's complete, it's then going to go ahead and rebuild that index using the specified compression. Let's go ahead and take a look at a data compression statement and go ahead and run it and see what happens with the data. As you can see here, SQL Server Management Studio, I've already got the command there. This command is actually a little bit different than the one that I had in the slide deck. In the slide deck it said alter index, whereas here I'm saying alter table. So the reason I'm doing an altered table here is because this table is actually a heap. So if I look at the properties of the table, look at the storage tab, I'll see my compression type is none. And I'm currently using 4.9 megs of space. So if we go ahead and turn on data compression by running this statement, when we pull up properties again, we'll see we're now using page compression, and we're using a little bit less space, 4.2 megs as opposed to 4.9. This isn't a huge amount of space savings, but this is just a sample table, and I don't want to sit here and run a data compression on a billion row table, so you can get a good idea how much space is saved. So in the real world, if I was to run that on a large billion plus row table, I could get a substantial amount of space savings. One of my customers, for example, when I compressed one of their 1.2 billion row tables, the original table was taking right around a terabyte of hard drive space. The post-compressed version of the table was taking up about 450 gigs of space. So that's a huge amount of space savings, and that's a huge amount of money savings, because that means that they don't have to buy storage for that table for a good long time, because they already have the storage allocated. Now it's just a matter of reusing it now that the data is all compressed. So in summary, we've got two kinds of compression that are supported within SQL Server. We've got row level and we've got page level. We never want to try to use anything like NTSF compression on our databases, because that's not going to work. It's not going to save us anything. The space savings is always going to vary depending on the data that's being stored. As you're changing that data, you're actually going to be changing the amount of compression that you get as you're modifying those values. Don't forget, always take a look at the SP_estimate data compression savings system store procedure to find out what you're going to get for data compression on your table so that you know in advance how much savings you're going to get. Because the worst thing you can do is spend hours or days compressing a table, generating billions of I/O, and get nothing out of it.